So we have a problem here that can be solved mathematically. What we're going to do first of all is say that the adult ticket, or the number of adults, is X, and the number of children is Y. Now we know that there were 1,000 tickets sold, so the total number of adult and child's tickets is 1,000. That's the first of our two equations. The next thing we know is that an adult ticket costs $8.50 and a child's costs $4.50. So an adult ticket costs $5.50 and a children's ticket costs £4.50. Well, let's consider this. Each adult ticket is $8.50 and we've got X adults. Now how do we put those two quantities together? Well, if we want to work out the total amount of money raised by selling adult tickets, it would be the cost per ticket, which is $8.50, multiplied by the number of adults. So if we had 10 adults, it would be 10 times $8.50, 20 adults, it would be 20 times $8.50, but we don't know the number of adults, or rather, so we've let it be equal X. That means we've got £8.50 or $8.50 times X. So 8.5 X. We've got each child's ticket costs $4.50, and there are Y children. So how do we put those together? Well, if I had 10 children, that'd be 10 times $4.50. If I had 20 children, it'd be 20 times $4.50. But I don't know the exact number of children. I only know that there are Y children. So that would be $4.50 times Y. And I can write that as 4.5Y. And the total raised by selling tickets was 7,300. So there's the second equation. Equation 1 and equation 2. Now, which of the two is easier to eliminate? I'm just going to choose to eliminate Y. What I'm going to have to do is to multiply equation 1 by 4.5. So, that would give us 4.5x plus 4.5y. 4.5 times 1,000 is 4,500. That's equation 1. And underneath it I'll write equation 2 again. So I've got the same number and the same sign. I'm going to subtract one equation from the other. Equation 2, because the numbers in that equation are larger. Equation 2 take away equation 1. 8.5 take away 4.5 is 4x. 4.5y take away 4.5y is 0. 7,300 take away 4,500 is 2,800. If I divide by 4, I get 2,800 divided by 4 is 700. And that means there were 700 adults. 700 adults. Well, we know that we've got a total of 1,000 adults and children. So if I substitute x equals 700 into equation 1, very simple equation to work with. 700 plus y equals 1,000, and y then equals 300. Now what we have to do to make it absolutely clear is to state that we have 700 adults and 300 children. The cost of an adult ticket and that'd be X, and the cost of a child's ticket can be y. Now, let's look at the first sentence. So it's Mr. and Mrs. Smith. That's 2 adults. Take their 2 children. So that's 2y. And the cost is £33. So we can make an equation from that. 2x plus 2y equals £33. Mr. Jones. Mr. Jones is 1 adult, so that's a single x. Takes his 3 children. So that'd be 3y. And the total cost is £27.50. So 1x plus 3y equals £27.50. And we'll number the equations 1 and 2. And I think I'm going to try to eliminate x. I'll do that by multiplying equation 2 by 2. What does that give me? 2 times x is 2x, 2 times 3y is 6y, 27.50 times 2 is £55. That's equation 2, so I'll write equation 1 underneath that so that they're together. I'm going to subtract one equation from the other. So equation 2 take away equation 1. So 2x take away 2x is 0. 6y take away 2y is 4y. And 55 take away 33 is 22. So if I divide by 4, 22 over 4 is £5.50. And what I want to do next is to work out the cost of an adult's ticket. That's the value of x, so I'm going to have to substitute that back into one or other of the 2 equations. I'll just use equation 1, I think. So what does that give us? 2x plus 2y that's plus 11 equals 33. Subtract 11 from both sides, 2x equals 22, and then x equals £11. So the cost of an adult ticket, that's £11, and the cost of a child's ticket is £5.50.